I've told you before that science proceeds by proposing models and theories and then testing them by means of experiment. As a matter of fact, there's a point of view that says that the only way that science can make progress is by showing that theories are wrong. The argument goes like this. It's impossible to prove that a theory is right, no matter how many experiments agree with it. But if one single experiment disagrees with it, then the theory must be wrong. Well, that itself is a theory of knowledge which is wrong, because there are theories in science which are so well verified by experience that they become promoted to the status of fact. One example is the special theory of relativity. It's still called a theory for historical reasons, but it is, in reality, a simple engineering fact routinely used in the design of giant machines like nuclear particle accelerators, which always work perfectly. Another example of that sort of thing is the theory of evolution. These are called theories, but they are in reality among the best established facts in all of human knowledge. Well, our job today is to look into those facts and theories and models which underlie our understanding of the ultimate constituents of matter.
The long and winding road to the atom, from the atom itself to the nucleus, and on toward the ultimate constituents of matter, is designated by landmark theories and models. This model showed atoms streaking through space, bouncing off walls, and creating pressure in the process. This one illustrated how gas atoms interact and how they bind into liquids and solids. And this one gets right into atoms as they form molecules. Here's the atom, pictured as an ion with a loosely bound outer electron. That picture helped to explain the formation of metals. Still, the question is, why are there so many models? In other words, why doesn't someone just take a peek inside to see what an atom really looks like? Because to be seen, an object has to be large enough to reflect light. And the largest atom is 1,000 times smaller than a wavelength of light. In the literal sense, no atom will ever be seen. And to make matters very much worse, the nucleus is perhaps 100,000 times smaller than an atom. And yet, the job of this apparatus is to investigate not what an atom looks like, and not even what a nucleus looks like. Its job is to investigate the inner working parts of the protons and neutrons that are, themselves, the inner parts of the nucleus. To do that requires some very impressive machinery. That machinery exists here at the Fermi National Accelerator Laboratory near Chicago. However, to do the job also requires a new kind of mental machinery, a way of constructing and testing models that permit the mind's eye to see that which the real eye cannot. That machinery, it's called quantum mechanics, began with a model of the hydrogen atom proposed by Niels Bohr. In the Bohr model of the atom, the electron can exist only in certain orbits. Orbits in which the electron circles the nucleus as if it were a planet going around the sun. Louis de Broglie suggested why. Electrons are waves that can exist only in orbits where they interfere constructively. And that can happen only if the circumference of the orbit is equal to the wavelength, or twice the wavelength, or 3 times the wavelength, or for that matter, any integer n times the wavelength. But brilliant as that idea was, it would not be the final word.